Segasonicfan here. Okay, I got my SIIG LED light hack pretty much done here. And there's two minor things that I may fix at a later date. I guess three. One is that let me explain a little bit here. So this is for those that didn't see the other part of the video, this is a folding LED light that folds open when there's not tape stuck to it. Folds open like so. Has a touch sensitive, dimmable LED light. Super bright, super nice. It also has a CR2032 spot in the back there, which creates a date and time and alarm clock and stuff like that too, which is kind of cool, and temperature, which is actually quite nice. And I decided to expand it by giving it a much better battery. This is about 8 times the power of the original battery. It's 4 18650 lithium-ion cells. And what else? Oh, I wanted to give it a better charger because the original charger is really dinky, and the built-in circuit and just does not charge it as fast as it uses the power, even at full brightness. So that's not ideal. The other thing, lastly, that I added was a step-up regulator, a DC to DC converter, so that it would stay at a consistent voltage so that the brightness doesn't dim based on the battery's voltage dropping, because it is connected directly to the LED when it's powered on through a N-channel MOSFET. So yeah, by keeping the voltage a constant voltage, the current will obviously change as the battery runs out of juice, but it won't dim the light. And so I really wanted that. And this is the step-up converter that I designed. These are both my own designs. And this is the lithium-ion improved charger that I designed, those two boards in there. And it works pretty great right now. I've already been using it as a reading light, work light, other stuff. It's great. A couple minor things. So one is that the battery has to constantly be tied to the main circuit under here, which, by the way, is an SGL 8023W, I believe. The SGL dimmable light ICs are pretty cool. You can get them around. They're getting more common to buy now online and stuff. The 8022, I think, is more common right now. And the battery has to be tied directly to this, because otherwise that touch sensor, that's what turns it on. And so if I didn't do that, then I'd have to come up with, it'd be pretty hard, actually, because that circuit is an all-in-one kind of circuit. It has the latching circuitry and the capacitive touch circuitry built into the same chip, so you pretty much have to power it to turn that off and on if you want to use the original off and on touch sensor, which you kind of have to. As a result of that, and I'm not sure how they did it with their charger, but with my charger, as a result of that, it never goes green, like it never says fully charged, because it's going to stay red. Here it is when I plug it in. You see the red light there. It's going to stay red because there's always a tiny bit of current going to this IC, and I'm pretty sure that's the reason why it's going to stay red all the time, even when it's fully charged. Not a big deal. It would just be nice for it to turn green, and it's done charging. That would be nice. So that's the first, number one of the 3 minor things. Number 2 is this case right now. I'm just holding it on with tape. I might use a silicone solution later on down the road, but that's not ideal either. There are 4 screw posts here, but they're really tiny, and they're like M1s. I 3D printed this case here with the help of a friend, but and I could drill the holes theoretically, but finding screws that are that small that'll actually work, I mean, I don't even know if it'll take the weight of this battery very well, with the very thin clearance in the plastic here. And I was thinking I could retap it with M2s and do some stuff, but I don't know. That one's a little bit tricky. So that's problem number 2. Minor problem number 2. Minor problem number 3 is that this board right now is set at 5 volts out, constant 5 volts out to this board, which is, the board can do up to 5.5. I imagine the LEDs can handle that too. What I noticed, though, is there's not a significant increase in brightness between 4.2 and 5. In fact, not only is there not a significant increase in brightness, I think the extra voltage is actually burned off by the LEDs. And so actually you just want to keep it at a steady 4.2 or 4.3. I don't need to keep it at a 5 volts all the time to create the extra heat. So I actually would like to take this out, change the resistor, the feedback resistor, to change it to a lower, slightly lower voltage, and then it won't create as much heat, less power loss, etc., etc. So those are the 3 minor changes that I'd like to do eventually with this thing, but I won't do them today. Just wanted to document it, and see if I can get this tape out here. See if I can put it all together. It's kind of hard to put everything together with one hand, but I'm going to do my best. And when you put it all together, it actually looks pretty slick minus the tape. It came out pretty nice with the Prussia 3D printer. And I'm still pretty new to 3D printing, so I can't take too much credit for it. I did design the case, but I didn't do the slicing software or anything like that, which I know is not super complicated, but I still have yet to learn some of that stuff. So we get the tape on here. Well, this one got stuck to itself. Let's fix that. White electrical tape gets so dirty so quick, or at least it's visible. I guess other tape gets just as dirty, but and there you go. It's all set up in one piece now. And you know, it's fine with the tape. It holds together. It's just an aesthetic thing mostly. And there it is. Turns on. It dims. Turns off. One cool thing that I designed almost by accident was the indication of charging indicator. I don't know if you can make that out. Yeah, there you go. It's cool. This plastic is white and it's thin enough that the LED will actually shine through it. That's pretty awesome. Also, there's a red LED for the step-up converter when it's active. So when I turn this on, that goes on too. You can see it through the case, which is really nice. Nice little indication without having to drill holes. One other thing I should note is that I did need to add an extra N-channel FET inside here on the main board, because that uses a FET, or actually it's a transistor in the original design, to switch on the LEDs. There's a logic level signal that goes to the FET, and when it's high, when it's 5 volts or 3.7, whatever your battery is, then it'll switch the ground signal. The ground signal will connect to the negative side of the LEDs here, like a FET, like an N-channel FET normally works as a switch, and turns it on. When I first was using the step-up converter, though, with 5 volts, it started to smoke and burn. And that's because it couldn't handle the higher voltage and current that I was putting through it. So I had to add a beefier N-channel FET there. The other thing I did, which I thought was a little clever, was I wanted to find a way to switch on the step-up converter when I switched on the rest of the circuit, which is tricky because the circuit is powered by the step-up converter. The way I did that was that same logic level signal going to the N-channel FET, I fed to the input of the step-up converter with a 1 kilo ohm resistor to be on the safe side, and then put a diode in series with the battery going to the SGL chip, so that it's always powered through some, micro voltage and microcurrent, I should say, and that way there's always a signal that gate for the N-channel FET is always powering down the step-up converter until you hit the on switch, the on button. And so that's a little trick I came up with. I also had to put a diode in series with the step-up converter and the main board so that the battery voltage doesn't feed into the main board and then into the output of the step-up converter. So it requires 2 diodes, 1 resistor, and that N-channel FET, as I mentioned before. Those were the extra parts needed. Works pretty well. The downside, of course, is you get the loss with the voltage drop across the diode. If I really cared, I could use some fancy Schottky diodes, but I don't care because this thing has 8 times the power. This thing is going to last a really long time on batteries, which is why I did this. And it's now going to be my #1 LED portable light. This thing rules. It's really good. I wouldn't have done all this work if it wasn't a really great light. And you can't really tell in this video, especially because it's light out right now. But it's a fantastic folding light. Saved my butt many times. So if you're crazy enough like me and you want to do something like this, feel free to leave a comment or let me know. I can get you these 2 boards that I have in here, and yeah, or not, you know, have fun hacking LED lights and stuff. This is Segasonic Fan, signing out.